Hello everyone, this is our session 9 on differentiation. We were on exercise 1.2 question 1. Okay, so the questions are comparatively simpler, but we'll do one more of that type and then move on to question 2. Okay, so I'm doing the 8th question now, exercise 1.2. Question 1. Okay, I'm doing the 8th one. The question was, one second. Yeah, so we had to differentiate the inverse function, that is, find the derivative of the function y equal to fx using the derivative of the inverse function x is equal to f inverse y. That means first we'll express x in terms of y, okay, x equal to something, and then we will differentiate it. So I'm taking the 8th one now. So it is y is equal to, y is equal to log of x by 2 to the base 2. So log of x by 2 to the base 2. Right? So let us express this in terms of x equal to. So how will we do that? This will be 2 raised to y is equal to x upon 2. Therefore, x is equal to 2 into 2 raised to y. Now what we'll do is differentiate with respect to y, that is dx by dy. Okay, so how will we solve that? So dx by dy, okay, is equal to 2 as it is, 2 raised to y, that is a raised to f of x is equal to a raised to x into, a raised to f of x into log of a, so log of 2. Okay, so this is our dx by dy. Okay, now how do we find dy by dx? So the theorem on inverse function says that dy by dx is reciprocal of the inverse function, or the inverse function is reciprocal of dy by dx. So this will be dy by dx is equal to 1 upon dx by dy, right? So this will be 1 upon 2 into 2 raised to y log of 2, right? So what we'll do is we'll substitute what is y. What is y? It is log to the base 2 x by 2. So we have 1 upon 2, 2 raised to log to the base 2 x by 2 into log of 2. Okay. So now 2 log 2 is a constant. We'll leave it here aside. We have 2 log to the base 2. Now if you have anything like this, what is the answer? It is the function itself. That is, if we have x, or rather we would say not x, how about e log to the base e of x? If we have this, then the answer is x. Similarly, if the base of the log and the base raised to function is the same, then e log e cancels out, we get the answer as x. So similarly, 2 log to the base 2 will cancel out and we'll get x by 2 over here, okay, which will be 2 upon x into 2 log 2, so 2 will cancel out. So the answer is 1 upon x log 2. Final answer of dy by dx using inverse functions. Yeah, this is question 8. Now we are moving to question 2. Okay. Now question 2 says that differentiate, find the derivatives of the inverse functions of the following. Okay. So what we'll do is we'll take down the first sum. Now here they've not told you to derive the inverse function first. Okay, so what we'll do is we'll find dy by dx, use the theorem, and then get dx by dy. That is reciprocal. So y is equal to, one second, y is equal to x square e raised to x. Okay, so what we'll do is we'll say differentiate with respect to x only. So we get dy by dx is equal to, we'll use multiplication rule here, first term as it is, derivative of the second, plus second term as it is, derivative of the first. E raised to x derivative remains as e raised to x and x square derivative is 2x. Okay. Then what can be the simplified form of it? Dy by dx is equal to, we have x e raised to x common. We're left with x plus 2. Okay. This is dy by dx. They have asked you to find the derivative of the inverse function. So that will be dx by dy, right? So what we'll write over here is, using theorem on inverse function, using theorem on inverse functions. What is the theorem? It says that dy by dx, or rather we are finding the inverse function, so we'll write dx by dy, okay, that is x with respect to y is equal to 1 upon dy by dx. Also you can write 1 upon f, if you have a f of x function, then f dash of x. Okay, and dx by dy can also be mentioned as f inverse x dash, like this. Okay, so f inverse x is f of y, you can say, or it is, you can call it a different function, g of x, and then put it over here. Okay, this is the theorem. Therefore, dx by dy is what we have to find, is equal to 1 upon dy by dx. Now, what is our dy by dx? 1 upon, it is x e raised to x, x plus 2. So, x e raised to x, x plus 2. This is your final answer. Dx by dy is equal to this. Yes, 1 upon dy by dx, reciprocal. Clear? So I guess question 2, how to solve, we are clear. I'll just do one more sum of this type so that the steps are known. So we have a second question that says y is equal to x cos x, right? So again, we'll do normal differentiation, dy by dx. You can say differentiating with respect to x. Okay, so dy by dx is equal to first term as it is, derivative of the second, plus second term as it is, derivative of the first. Okay, we are using multiplication rule over here. So you're going to get cos x minus x sin x, right? And then what will be dx by dy? By theorem on inverse functions, dx by dy is 1 upon dy by dx. So just put it in reciprocal form, 1 upon cos of x minus x sin x. Yes, this is the second question. So question 2 is simple. I think we can do the rest of them on our own. We'll move on to question 3. So question 3 says that find the derivative of the inverse of the following functions and also find their value at the point indicated against them. Right? Yes. So question 3, the first one, let us do that. So we have y equal to x raised to 5 plus 2x cubed plus 3x. Okay. What we have to do is find its inverse function, okay, and then find the value of the inverse function at the point mentioned. I'll just read out the question again. It says find the derivative of the inverse of the following functions and also find their value at the points indicated against them. So once we'll find the inverse derivative, so first let us go by dy by dx, which is equal to 5x raised to 4 plus 6x square plus 3, right? Dx by dy is equal to 1 upon dy by dx, right? So we'll take the reciprocal of the function 5x raised to 4 plus 6x square plus 3, right? This is dx by dy, and now dx by dy at x equal to 1. So we'll say at x equal to 1 is equal to 1 upon 5, 1 raised to 4 plus 6, 1 raised to 2 plus 3. Just substitute the value of the point and get the answer. So we have 5 plus 6, 11 plus 3, 14, 1 upon 14. So question 3 is pretty simple. Just find the inverse. First find the derivative, then the inverse, and then you can find the value at the point mentioned for x. Okay. Let us go to next question, question 4. So question 4 says is f of x is given to you. So what is f of x? Let's write that. Question 4, we have f of x equal to x cube plus x minus 2. Okay. And find f inverse dash of 0, they have said. So find f inverse dash of 0. That means dash means derivative, inverse derivative. So first let us find f dash of x, right? That is dy by dx, right? So differentiate x. Sorry, differentiate f of x with respect to x. So we have 3x square plus 1 as your derivative, f dash of x. Now, what is f inverse dash of x? What it will be? It will be 1 upon f dash of x, okay, which is equal to 1 upon 3x square plus 1. Last step, if I have to find f inverse dash of 0, so instead of x, I will write 0 and substitute it over here in the answer. 3 into 0 plus 1, so answer is 1. Okay, that is how you find f inverse of a particular value of x. Okay, that is question 4. Now let's move on to question 5. So question 5 says that prove that, we have proved that sum now, prove that tan inverse of x plus cot inverse of x is equal to pi by 2. Okay, this is what we have to prove. So let us start with the LHS first. Okay, so LHS is equal to tan inverse of x plus cot inverse of x. Now, if you remember that inverse tables, okay, if you want, I can show you the inverse table so that we know the values of tan inverse and cot inverse. Okay, just a minute. Yes. So let us see what is the formula for tan inverse and cot inverse. Okay, so we have it here. So yeah, tan inverse x over here, if you can see, it is 1 upon 1 plus x square, and cot inverse x is minus 1 upon 1 plus x square. Let us substitute these values in the sum. Yes, so we've seen the derivative values of tan inverse and cot inverse. Now, how do we start with the sum? We say that differentiating the left hand side, okay, with respect to x. So differentiate with respect to x. We'll call the left hand side as f of x. Okay. So differentiating f of x with respect to x, f dash of x is equal to d by dx of tan inverse of x, yeah, plus d by dx of cot inverse of x. Okay. So what is the answer for tan inverse? It is 1 upon 1 plus x square minus 1 upon 1 plus x square, negative value, right? So what are we getting? The answer is 0. And what is the derivative of a 0 or a constant number? It is a constant number, right? 0 is a constant number. So f dash x will always be a answer is 0. If f dash x is 0, it means what? Dx of this is equal to 0. D by dx of what function is equal to 0? Always remember d by dx of c. A constant term is always 0. That means f of x that we have. What is f of x? Check. F of x is this function here. So f of x is tan inverse of x plus cot inverse of x. what is the answer to this? It is always going to be a constant value. Now we have to find out what is this constant value. So for all values of x, whatever value I substitute in x, it will give me a constant value. Why? How can we say that? Because derivative of this f of x is coming out to be 0. It means the final answer is always a constant number, right? So what I'll say is, for x equal to 0, f of x or f of 0 is equal to tan inverse of 0 plus cot inverse of 0. What is tan inverse of 0? It is sine 0 upon cos 0. What is sine 0? 0. So the answer will be 0. What is cot inverse of 0? It is cos upon sine. So cos of 0 is pi by 2, right? So we are getting f of 0 as pi by 2. Therefore, we can say that tan inverse of x plus cot inverse of x is equal to pi by 2. Clear? So that is the final answer for tan inverse cot inverse. That is exactly what we had to prove, right? So at x equal to 0, I'm getting the answer as a constant value pi by 2. So LHS is equal to RHS, okay? Now, in this part, in this subpart, that is question 5, most of the sums are of the similar manner. I'll just read out the sums to you. So you have to prove it in the exact same manner. We did tan inverse plus cot inverse, and there is sec inverse x plus cosec inverse x is equal to pi by 2 for x greater than or equal to 1. Okay, we have to prove that with the same method. That is question 5. Now I'll move on to question 6. So question 6 is differentiate the following with respect to x. So I take down the first function. Question 6, first one, differentiate with respect to x. We have y equal to okay, we have y equal to, what is the sum? Tan inverse of log of x. So we have tan inverse of log of x. Okay, so how will we do this now? So we say dy by dx, differentiate with respect to x, is equal to d by dx of tan inverse function, right? Tan inverse log of x multiplied by d by dx of log of x, correct? Now, what is the property that we will use? So we have something like d by dx of tan inverse of f of x is equal to 1 upon 1 plus f of x the whole square, okay, multiplied by f dash of x, right? So what will we do? We have already done the f dash of x. We have already done the f dash of x over here, right? So we only have to substitute 1 upon 1 plus f of x the whole square. What is our f of x? It is log of x over here. So dy by dx will be equal to 1 upon 1 plus log of x the whole square, right, multiplied by derivative of log of x, that is 1 upon x. So the answer is 1 upon x, 1 plus log x the whole square, right? You can also write it as 1 plus 2 log of x. Yes, so let us move to the next one now. Same question 6. I'll do the second one, cosec inverse e raised to minus x. Okay, so second one, cosec inverse e raised to minus x. So let us first revise the formula for cosec inverse. What do we have? So I'll just take you to the list of formulas. Cosec inverse formula of x. Check the formula. Cosec inverse f of x is equal to minus 1 upon f of x root of f of x the whole square minus 1 multiplied by f dash of x. So let's write down the formula here. Okay. So cosec inverse f of x is equal to minus 1 upon f of x, right? Under root of f of x the whole square minus 1 multiplied by f dash of x. Okay, let us apply this formula here. So we write this as, let us take this as a function of y. Y is equal to cosec inverse of e raised to minus x. So dy by dx is equal to cosec inverse f of x will be minus 1 upon f of x, so e raised to minus x root of f of x the whole square e raised to minus x the whole square, right? And we have minus 1 multiplied by f dash of e raised to minus x. So if you take the derivative of e raised to minus x, what will that be? E raised to minus x derivative is minus e raised to minus x, so it will become plus e raised to minus x upon e raised to minus x square root of e raised to minus 2x minus 1. E raised to minus x cancels, so we are left with 1 upon e raised to minus 2x minus 1 square root, right? That is our final answer. Clear? So this was the second one. Let us move to the next one. If it's simple, we'll skip it and go to the next sum. Let me check the sum. Yes, so it says y is equal to cot inverse x cubed. We use the formula for cot inverse and f dash of x, that is 3x squared. So that is simple. Again, the fourth one is cot inverse 4 raised to x. Now, the function f of x itself is a raised to x. So what is the derivative of a raised to x? It is a raised to x log of a. Okay, remember the formula is correct here, and these sums are very simple. Okay, then the fifth one, tan inverse. Again, we'll use tan inverse formula 1 upon 1 plus x square, and your x square here is f of x the whole square. Okay, next, sixth one is sine inverse of a function. So let us do this sum. It says it's the sixth sum. So we'll do the sixth one now. We have y is equal to sine inverse of, okay, and you have a square root sine 1 plus x square upon 2. Okay, so we have to find the derivative of this sine inverse function. Okay, so y equal to sine inverse of root of 1 plus x square upon 2. Okay, what we need to know is the sine inverse function. So sine inverse f of x, what is its derivative? It is equal to 1 upon root of 1 minus f of x the whole square, right? Multiplied by f dash of x. This is what we'll use over here, right? So let us do dy by dx. So we get dy by dx is equal to, d by dx is the sine inverse function. So 1 upon under root of 1 minus f of x is this entire root function. So 1 plus x square by 2 the whole square, right? Yes, so this can be written multiplied by, then we have f of x, f dash of x. So f dash of x will be f dash of the entire root function 1 plus x square by 2. Okay. So our next step will be, we'll take LCM, rather we'll remove the root sign first. So 1 minus 1 plus x square upon 2, right? Multiplied by a root function means 2 root of 1 plus x square upon 2. okay, multiplied by f dash of what is left now, the inner function 1 plus x square upon 2. Okay, so let us simplify this. Dy by dx is equal to 1 upon under root of, now we'll take LCM for this term, so we get 2 minus 1, that is 1 minus x square. Okay, so this will be 1 minus x square divided by 2 multiplied by 1 upon 2 root, so I'll just put the root sign up, so we'll get root of 2 divided by 2 root of 1 plus x square. Okay, multiplied by half is a constant and 1 plus x square derivative is 2x. Okay, this is your okay, so this will be root sign going up, root 2 upon root of 1 minus x square into, we have root 2 upon 2 root of 1 plus x square, and this cancels, so we have into x. Okay, this root 2 and 2 will get cancelled, so we are left with x upon root of 1 minus x raised to 4. It is a minus or a square minus b square formula. A minus b, a plus b is a square minus b square. 1 square is 1 and x square is x raised to 4. So this is your final answer. So we finished till question 6. I think question 6 remaining questions should not be a problem. I'll just go through them once for you so that if there is a difficult problem, we can do it here. Okay, we were on the question 6, sixth one. So we can do 7th one is simple, 8th also is simple, 9th, yeah, 9th and 10th we'll have to solve. So in my next session, we'll begin with question 6, 9 and 10 and then move on to question 7. Okay. If you have any doubts regarding from 1 to 6 and you're solving, you have an issue or problem, do write to me. I'll give you the solution for the same. Yes. So we'll stop here for this session. Thank you very much.